Find the interval where the function is increasing or decreasing, then find both local and maximum extreme value. The function is f of x equals x plus 2 sine x on a closed interval. On a closed interval, we will be able to find the absolute mean and absolute max. First, f prime of x is 1 plus 2 cosine of x. The derivative of x is 1, and the derivative of sine of x is cosine of x. We set this equal to 0. 2 cosine of x equals negative 1, so cosine of x equals negative 1 over 2. We only need to find x on the interval 0 to 2 pi only. Cosine of x equals negative 1/2 when x is 2 pi over 3 and 4 pi over 3. Cosine of 2 pi over 3 is negative 1/2, and cosine of 4 pi over 3 is also negative 1/2. These are the two cut points, 2 pi over 3 and 4 pi over 3. They are the critical points in this closed interval. To determine the sign of f prime, we use the test point in each of these intervals. For the first interval, we use x equals pi over 2. For example, x equals pi over 2, plug this into f prime. We're looking for the sign of f prime, the first derivative. 1 plus 2 cosine of pi over 2 is, cosine of pi over 2 is 0, and so this is 1, which is positive, and so f prime is positive on the entire subinterval. Between 2 pi over 3 and 4 pi over 3, we use pi as a test point. F prime of pi is 1 plus 2 cosine of pi, but cosine of pi is negative 1, and so this is 1 minus 2, which is negative. And for the third interval, we can use 3 pi over 2 as a test point. F prime of 3 pi over 2 is 1 plus 2 cosine of 3 pi over 2. But cosine of 3 pi over 2 is 0, so this is 1, positive. We see that the function f is increasing on the interval 0 to 2 pi over 3, union with 4 pi over 3 to 2 pi. It is decreasing on the interval 2 pi over 3, 4 pi over 3. Since the function is increasing and then decreasing and then increasing, we see that f has a local maximum at x equals 2 pi over 3. It has a local minimum value at x equals 4 pi over 3. To find the local maximum and the local minimum value, we would need to plug these into the given function. But since we're looking for the absolute extreme values as well, we will make a table of the endpoints. They are 0 and 2 pi. And any critical points, we found two critical points, 2 pi over 3 and 4 pi over 3. We then plug this into the given function, which is x plus 2 sine of x. F of 0 is 0 plus 2 sine of 0, which is 0, because sine of 0 is 0. F of 2 pi is 2 pi plus 2 sine of 2 pi, but sine of 2 pi is 0, so this is 2 pi. F of 2 pi over 3 is 2 pi over 3 plus 2 times sine of 2 pi over 3. This is 2 pi over 3 plus 2. Sine of 2 pi over 3 is root 3 over 2. And so this is 2 pi over 3 plus root 3. f of 4 pi over 3 is 4 pi over 3 plus 2 sine of 4 pi over 3. This is 4 pi over 3 plus 2. Sine of 4 pi over 3 is negative root 3 over 2. And so this is 4 pi over 3 minus root 3. Now, we still need to determine which one is the largest number and which one is the smallest number. Pi is approximately 3.14, and so 4 pi over 3 is more than 4 minus root 3. It is positive for sure. 2 pi over 3 plus root 3 is also positive. 2 pi is positive, and 0, therefore, is the absolute minimum value. Out of these three positive values, 2 pi over 3 plus root 3, and 4 pi over 3 minus root 3, we see that 2 pi is the largest of them. So 2 pi is the absolute maximum value. How do we know that 2 pi is the largest out of these three? Pi is approximately 3.14, and so this is about 6.28. 2 pi over 3 is approximately 2 plus root 3. Root 3 is 1 point something, and so this is less than 4. This is about 1 minus something, so it is less than 6 for sure. And so we conclude that the absolute minimum value is 0, and it occurs at x equals 0. The absolute maximum value is 2 pi, and it occurs at x equals 2 pi. What about 4 pi over 3 and 2 pi over 3? 2 pi over 3, from the sign chart of f prime, we see that f has the local maximum at 2 pi over 3, and the local maximum value is 2 pi over 3 plus root 3. 4 pi over 3 minus root 3 is therefore the local minimum value, and it occurs at 4 pi over 3.